Imagine a wind turbine that doesn't spin, doesn't roar, and yet claims to outperform solar panels by a staggering margin. This isn't science fiction, it's Aeromine, a rooftop energy system that looks more like a futuristic sculpture than a traditional power generator. Designed to harness the invisible flow of air without any visible moving parts, Aeromine promises to slash energy costs by up to 70% compared to conventional solar panels. But does this radical innovation live up to the hype, or is it just another ambitious idea caught in the whirlwind of the green energy revolution? To uncover the truth, we must dive deep into the science, the secrets, and the surprising realities behind this groundbreaking technology. At first glance, Aeromine's sleek, curved panels standing upright on a rooftop seem more like an art installation than a power-generating machine.
Unlike traditional wind turbines with spinning blades, this system relies on a clever aerodynamic trick hidden beneath its smooth surface. The key lies in its specially shaped airfoils, which create low-pressure zones as wind flows over them, effectively sucking in surrounding air like a straw.
Beneath these panels sits a concealed turbine, driven by the airflow pulled through the system, silently converting wind energy into electricity. This design eliminates the need for external blades, reducing safety risks and making it more durable against harsh weather conditions. What's even more impressive is its ability to capture wind from multiple angles, maintaining efficiency even when the breeze isn't blowing head-on. It's a quiet revolution in wind energy, one that trades brute force for precision and pressure, redefining how we think about harnessing the wind. While Aeromine feels like a futuristic breakthrough, its underlying principle is surprisingly ancient. Thousands of years ago, Persian architects built wind catchers, tall towers that channeled desert breezes into homes for natural cooling. These structures didn't rely on fans or motors. Instead, they used pressure differences to draw cool air from underground aqueducts. Aeromine taps into the same age-old concept, but instead of cooling homes, it captures wind to generate electricity. The modern twist lies in its precision-engineered airfoils and advanced materials, transforming an ancient idea into a cutting-edge energy solution. This connection to history isn't just poetic, it's a powerful reminder that some of the best innovations come from reimagining old wisdom with new tools. Early prototypes of Aeromine showed promising results in controlled wind tunnel tests, maintaining steady power output even with shifting wind directions. Unlike traditional turbines, which lose efficiency when the wind changes angle, Aeromine's design keeps airflow smooth thanks to the Kanda effect, a fluid dynamics principle where air clings to curved surfaces. However, once wind veers beyond 45 degrees, its performance drops sharply, a limitation that could hinder its effectiveness in areas with erratic wind patterns. Engineers studied regional wind data to identify ideal locations, finding that while Aeromine excels in some areas, it struggles in others where wind is less predictable. This variability means the system isn't a one-size-fits-all solution. It thrives in places with consistent directional airflow, like open industrial rooftops. When it comes to raw efficiency, Aeromine converts about 25% of wind energy into electricity, far below the 50% achieved by top-tier traditional turbines. But efficiency alone doesn't tell the whole story, as Aeromine's modular design allows it to cover more rooftop space, potentially generating comparable total energy. The company claims its system can reduce energy costs by up to 70% compared to solar panels, but this hinges on wind speeds of at least 7 meters per second, a rarity on most urban rooftops. In reality, buildings surrounded by trees or other structures often experience slower, turbulent winds, drastically cutting into Aeromine's energy output. This discrepancy highlights the challenge of comparing rooftop wind systems to solar, which performs reliably even in diffuse light conditions. Aeromine's biggest strength, its compact, rooftop-friendly design, is also its greatest weakness in crowded urban environments. In wide-open industrial zones with steady winds, it can generate power efficiently and silently, making it an attractive alternative to solar. But in cities or suburban areas where buildings and trees disrupt airflow, its performance drops significantly, raising questions about its practicality. Unlike solar panels, which work in nearly any location with sunlight, Aeromine's success depends entirely on local wind conditions, a limitation that narrows its ideal use cases. This doesn't mean the technology is flawed, but rather that it's a specialized tool best suited for specific environments rather than a universal solution. One often overlooked advantage of Aeromine is its reduced reliance on steel, a major source of carbon emissions in traditional wind turbines. By eliminating towering metal structures, it offers a more sustainable alternative, especially as the steel industry shifts toward greener production methods.
Companies like Sweden's SSAB are pioneering fossil-free steel, using hydrogen instead of coal, which could further shrink Aeromine's carbon footprint in the future. This focus on sustainability extends beyond energy generation, positioning Aeromine as part of a broader movement toward cleaner manufacturing in the renewable sector.
Aeromine may not dethrone solar energy as the dominant rooftop power source, but it's far from a failed experiment. Its blend of ancient inspiration and modern engineering proves that wind power doesn't need spinning blades to be effective. In the right locations, open, windy rooftops, it could provide a silent, space-efficient alternative to solar panels. While it won't work everywhere, its existence pushes the boundaries of renewable energy, reminding us that innovation comes in many forms. As the world races toward a greener future, technologies like Aeromine may not be the silver bullet, but they're vital pieces in the complex puzzle of clean energy. For now, it stands as a fascinating experiment, one that could reshape how we think about wind power in urban spaces. And in the ever-evolving landscape of renewable energy, that's a breakthrough worth watching. Aeromine's innovative design has sparked excitement, but its real-world viability hinges on overcoming significant challenges.
The most pressing issue is its dependence on consistent wind speeds, which are rarely found in urban and suburban environments. Unlike solar panels that generate power even on cloudy days, Aeromine struggles when wind patterns are unpredictable or obstructed by buildings. This limitation forces a critical question: can rooftop wind energy ever compete with solar on a large scale? Experts argue that while Aeromine won't replace solar entirely, it could carve out a niche in specific industrial and commercial settings. Large warehouses, factories, and agricultural buildings with unobstructed rooftops are ideal candidates for this technology.
In these environments, steady wind currents and minimal turbulence allow Aeromine to operate near its maximum efficiency. However, residential areas where rooftops are smaller and surrounded by trees or neighboring structures pose a much tougher challenge.
Even in windy regions, the roughness of urban landscapes disrupts airflow, drastically reducing the system's energy output. This raises concerns about whether Aeromine can achieve widespread adoption or remain a specialized solution for select applications. The cost debate: is Aeromine really cheaper than solar? Aeromine's claim of being 70% more cost-effective than solar hinges on optimal conditions that many rooftops simply can't provide. The company's calculations assume wind speeds of 7 meters per second, a figure typically measured at higher altitudes, not at ground level. On most rooftops, especially in cities, wind speeds are closer to 4 to 5 meters per second, which significantly lowers energy production. When adjusted for real-world conditions, Aeromine's cost advantage shrinks, making solar a more reliable and predictable investment. Additionally, while Aeromine has fewer moving parts than traditional turbines, its installation and maintenance costs are still being evaluated. Solar panels, by contrast, have plummeted in price over the last decade and benefit from well-established supply chains and installation networks. For now, Aeromine's economic case remains strongest in niche markets where wind conditions align perfectly with its design strengths. The maintenance question, longevity versus hidden cost. One of Aeromine's biggest selling points is its durability, thanks to the absence of exposed moving parts. Unlike conventional wind turbines, which suffer from wear and tear on rotating blades, Aeromine's internal turbine is shielded from the elements.
This could translate to lower maintenance costs over time, a crucial factor for commercial operators seeking long-term savings. However, the system isn't entirely maintenance-free. Dust, debris, and even ice buildup could affect airflow and reduce efficiency. Cleaning and inspecting the internal components may require specialized labor, adding to operational expenses. Solar panels, while also requiring occasional cleaning, have a proven track record of minimal upkeep over decades.
Until Aeromine undergoes years of real-world testing, its maintenance advantages remain more theoretical than proven. The steel paradox, a hidden environmental trade-off. While Aeromine uses less steel than traditional turbines, its reliance on precision-engineered materials introduces other sustainability concerns.
The aluminum and composite materials in its airfoils require energy-intensive manufacturing processes, if not sourced. Responsibly, these materials could offset some of the system's carbon savings. The growing shift toward green steel, produced using hydrogen instead of coal, could help mitigate this issue in the future. But for now, the environmental footprint of Aeromine's production remains a question mark compared to increasingly recyclable solar panels. This paradox highlights the complexity of judging clean energy technologies solely on their operational benefits. The noise factor, a silent but significant advantage. One area where Aeromine clearly outperforms traditional wind turbines is noise, or rather, the lack of it. Without spinning blades, the system generates almost no audible sound, making it ideal for noise-sensitive environments. This could be a game-changer for businesses like hospitals, schools, or offices that want renewable energy without disruptive hums or vibrations. Solar panels, while also silent, don't offer the same after-dark generation that Aeromine can provide in windy conditions. This after-hours energy production could make Aeromine a valuable supplement to solar, especially in regions with strong nighttime winds. The hybrid solution, could Aeromine and solar work together? Rather than positioning Aeromine as a solar killer, some experts suggest pairing it with photovoltaic systems for optimal energy generation. During the day, solar panels could dominate production, while Aeromine could take over at night or during windy, overcast periods. This hybrid approach would maximize rooftop space and provide a more consistent energy output than either technology alone. Pilot projects testing this combination are already underway, with early results showing promising synergies. If successful, such systems could become a blueprint for the next generation of commercial renewable energy installations. Aeromine's future will depend largely on its ability to scale production and demonstrate real-world reliability. The company is currently focused on commercial and industrial deployments, where the economics make most sense. Residential applications seem unlikely in the near term, given the system's sensitivity to wind conditions. As battery storage technology improves, Aeromine's intermittent generation could become less of a drawback, but for now, it remains a complementary player in the renewable energy ecosystem rather than a dominant force. Aeromine represents a fascinating evolution in wind energy, proving that innovation doesn't always mean bigger blades or taller towers. Its clever use of aerodynamics and low-profile design opens new possibilities for urban wind harvesting. However, the challenges of real-world wind conditions, cost competitiveness, and material sustainability can't be ignored. For now, Aeromine is best viewed as a promising niche technology rather than a solar panel replacement. But in the race to decarbonize our energy systems, even niche solutions can play a vital role. As the technology matures and finds its ideal applications, Aeromine could quietly carve out its own space in the renewable energy landscape. And sometimes that's how real progress begins, not with a roar, but with a whisper.